Well, hello again, welcome to the VK6CS Amateur Radio channel. I was up at the club yesterday and someone said to me that a couple of the local AM radio stations use the same antenna mast. I said, how do they do that? And the answer is they use something called a diplexer. Now, if there's two transmitters, or if there's three, it'd be a triplexer. And basically all it means is, a diplexer means two sources to one output or antenna. So a diplexer, still got this tripod in the way, a diplexer will have input 1, input 2. It will go through a matching and filter unit. Both will go through a matching and filter unit, and there'll be one common output, which will be the antenna. Now, if these are two transmitters, well, actually, yeah, what's the difference between a diplexer and a duplexer? Well, a duplexer, the actual schematics are very similar. So a diplexer will combine two transmitters onto one antenna. So this filter matching unit here will pass input 1 frequency through to the antenna. It'll provide a nice a low impedance for transmitter 1 to reach to the antenna, but for transmitter 2 it'll provide a high impedance. So in here will be a pass filter for the frequency we're interested in and a reject filter for the frequency of input 2, and vice versa. So on this one you will have, this will be tuned to be a nice low impedance for transmitter 2 to go through to the antenna, and it'll be a high impedance to transmitter 1, so it won't be able to get back through there. And that's a diplexer. Now a duplexer is very, very similar. Instead of having two transmitters, you would have one transmitter and one receiver. The actual filtering arrangement would be the same, so that on the transmitter you would have, this would be a low impedance to the transmit frequency, go through to the antenna. It would also have a reject in here to reject the receiver frequency, so that any transmitter components that would fall within that, within the bandwidth of the receiver input, would be attenuated. And the receiver here, that would be a nice low impedance for the receive path, and it will reject the transmit frequency. It'll have a rejection filter for the transmit frequency. And the duplexer means that you can transmit and receive at the same time, so you don't have to turn the transmitter off to listen. You can transmit and receive at the same time, because the filtering, the way it's filtered, is good enough that the transmit signal and the components of the transmit signal that fall within the receiver bandwidth are attenuated enough that the receiver can't hear it. Excuse me. So that's the difference really between a diplexer and a duplexer. So a diplexer, two transmitters to one antenna; duplexer, transmitter and receiver to one antenna. Now there are different types of duplexer. If this was a diplexer for combining two AM radio stations, it would be if it was a couple of low power stations, say a couple of kilowatts or so, this would probably be about as big as a fridge, and it would contain components that look a bit like that, sort of air-spaced variable capacitors, and roller inductors, variable inductors. You know, you see those coils with the little wheel that runs up and down, so you can adjust the amount of inductance. They would have those sort of components in them. If it was VHF or UHF, it would be cavity type filters. They're usually sort of quarter wave cavity filters, which are cylindrical things. Actually, I could probably show you one of those. First, I'll show you this thing here. This is called a duplexer. 144 and 440 meg duplexer. I don't think it actually is a duplexer. I think this is more of a diplexer, because I don't think, looking at the size of this, I don't think it's going to let me transmit and receive. This is the antenna port here on the antenna at the same time. I haven't actually tried it, because I use this connected to my Yaesu FT736R, which is a 2-meter 70cm radio. It's got a 2-meter port on it, and it's got a 70cm port on it, and of course, so I would have, you know, the 2 ports on this connected to the VHF and UHF ports on the radio. But if I'm on 2 meters and I press the PTT, I'm not listening while I'm transmitting. That particular radio I don't think will let me listen on 70 centimeters while I'm transmitting. I haven't actually tried that. And then I release the PTT, and of course I hear it, and it doesn't bother the 70 centimeter receiver. Doesn't bother the 2-meter receiver, because you know, when you press the PTT, the receivers are disabled. So, you know, it's probably not a duplexer. It's very broad band. As you can see, you've got a VHF and you've got a UHF, so you know the actual bandwidth of these filters. This will be nice and wide for 2 meters, so you can put any 2-meter frequencies through it. But it will present a high impedance to the UHF signal that's going through the other side of it out to the antenna, and vice versa. So this one will be a nice low impedance for the UHF, and it won't allow the VHF back into the UHF port. So I would say that's more of a diplexer than a duplexer, to be honest. I doubt you could use that for duplex, because remember, duplex means that you can transmit and receive at the same time. So if you're listening to a 2-meter repeater, the operation of that repeater, the signal's going in through the antenna down into the receiver through the filter, and the transmitter is transmitting energy out through its filter and up the same antenna at the same time. That's what they call full duplex. So I'll just pause this and I'll show you a commercial transmit combiner from a communications site. So this would be fairly low power, probably up to 50 watts or so, but 2 transmitters, and there's 1 receiver port on it. Let's pause this. Okay, so this is something that's a little bit bigger than that little thing I just showed you. This I'll zoom out a bit. Okay, there's the antenna port there. And we have these cavity filters. Now these are quarter wave cavity filters for VHF. You can see they're sort of fairly sizable things. And there's the common antenna port. And then moving along the string of filters, we have a transmitter that would have been connected there on this particular frequency. We have a receiver that would have been connected here. Well, that probably went to a receive splitter. So that would actually give you a couple of receive ports. And you've got another transmitter there. Now this transmitter here, 166525, if we go over here, we've got a 166525 reject filter, and that's connected here to this transmitter here. So this transmitter here, that'll be transmitter, this is 16867, so you've got these pass filters here that are coming through to the antenna, providing a nice low impedance for that particular frequency. And this would actually be a shunt for the other transmitter frequency. Okay, so these will provide a nice low impedance for, this will provide a nice 50 ohm impedance for this transmitter, but it will provide a high impedance for that transmitter. So that transmitter will come along here, nice low impedance for the transmit energy from this frequency up here to the antenna, but a very high impedance through these filters for the other transmit frequency. So it will come along here. Anything that does get through these, remember these are providing a very high impedance to the other transmitter frequency, but when we finally get to this port, the actual transmitter port here, we've got another filter there that's tuned to reject that. So if anything gets back to here, it gets rejected. And on the other side, we've got the same thing. So got those filters coming along here, nice low impedance for that transmit frequency, along here to the antenna port there. And going back down this string, the middle string, we've got the receiver, and that will be presenting a high impedance to both transmitter frequencies. And just in case there's any energy there, we've got a reject there for the other transmit. The other transmit frequency is being rejected by that can there. So that's what a bigger transmit combiner looks like. So that's a commercial communications combiner for VHF, as you probably gathered there from the frequencies. So that's what something like that looks like. So if you've got you know, a communications site, and you've got two or three base stations, and there's only one antenna, then what's going to be in there is something like this. And as I said before, you know, if you're talking about combining a couple of broadcasting stations, then you wouldn't be using cavity filters, because remember these are quarter wave long. These filters, so quarter wave at 160 odd megs. Yeah, imagine a quarter wave on the AM broadcast band, and what would you be talking about? I mean, supposing it was on 260 meters, I think that's about in the middle of the broadcast band. So quarter of that would be what, 130. So 65 meters. You'd have to have cans. These cans would have to be 65 meters long. The other thing too, of course, is that you'd want the tune to be reasonably wide, so that it wouldn't affect your modulation. But they tend to be variable inductors and variable capacitors, rather than this type of filter. But if you drew the actual electrical circuit, they're pretty much the same. You know, you've got a well, if you drew a schematic, they're more or less the same, where you've got pass and reject filters, but you either use variable capacitors and inductors, or use these coaxial quarter wave cans that do the same thing. Well, I hope you found that interesting, or informative, or both, as usual. Thanks for watching. I'll catch you next time.